Hello, guys. Welcome to Roland High School Math Room. Today, our studies is on the nature of root of a quadratic equation. Particularly, we are going to deal with the discriminant. And what are the root of quadratic equation? Root of a quadratic equation are values of x that satisfies the equation ax squared plus bx plus c equal to 0. Now, they are the values of x that makes the equation true, and they can be found by factorization or completing the squares or quadratic formula or by graphing. So, in general, when we talk about the root, then the root may be a real number or a complex number. So we are talking about real numbers or complex numbers. And these roots are the values that will make the equation true for both the left side and the right side. So here, for a quadratic equation of the form ax squared plus bx plus c equal to 0, the root of the equation is given by x equal to minus b plus or minus square root of b squared minus 4ac, all divided by 2a. So this is how we can also find the root. So that is what we call the quadratic formula. So here we need to use the quadratic formula to understand the concept called the discriminant. Now, from the root equation given by x equal to minus b plus or minus square root of b squared minus 4ac divided by 2a, the value of the expression b squared minus 4ac is known as the discriminant. And in this class, I am denoting the discriminant as d, which determines the nature of the root of the quadratic equation. As we said, the root might be real numbers or complex numbers. So the root will be determined, can be determined anytime we get to know the value of the discriminant. So which means that per our explanation or understanding, the discriminant, the d, can be equal to or is equal to b squared minus 4ac. So one thing that we need to put in mind is that there are three possible cases of the discriminant, which will help us to determine the nature of the root of the quadratic equation. So the three possible cases of the discriminant to determine the nature of the root are, first of all, if we calculate or evaluate the discriminant and end up getting the discriminant to be greater than 0, what are the possible roots that we are likely to get from the quadratic equation? We also get another case where the discriminant can be equal to 0. We are also going to get another case where the discriminant will be less than 0. Now, let's get to understand the full concept of the cases of the discriminant. We have the case 1, which the discriminant is greater than 0. So if the discriminant is greater than 0, it means that we are going to have two real numbers, that is two real roots. So let's see an example here. We have x squared minus 5x plus 6 equal to 0. The a is 1, b is minus 5, and c is 6. When you substitute these values in the discriminant and evaluate the expression, our d will be equal to 1. which means that the 1 is greater than 0. As such, we are going to get two real numbers as our answer. So when you sketch the graph of this particular function or equation, we are going to end up seeing two answers for x. That is, the graph is intersecting this x-axis at two particular points. That is, at the point where x is equal to 2 and at the point where x is equal to 3. And these are real numbers, real roots. Now let's move to the case 2 where the discriminant will be equal to 0. So when it happens like that, it means the expression under the root sign will be 0 and our answer will be only one answer, which is minus b over 2a, which implies that if the discriminant is equal to 0, we are going to have only one real number, that is equal root, as our answer. So we have an example of the form x squared minus 4x plus 4 equal to 0. So here, let's substitute the value of b, a, and c at where they are supposed to be in the discriminant expression. When we do that, we are going to end up with an evaluation answer of 0. So which means that the discriminant is equal to 0. As such, we are going to have only one real number or real root. So when you plot the graph or sketch the graph of this particular function, the curve will intersect the x-axis at the point where x is equal to 2. Only one point of intersection. It means that there is a tangent to the curve at the point where x is equal to 2. Only one real number. So now, let's move to the case 3. Which is also in the form d is less than 0. So for case 3, it means that the discriminant is negative, and anytime there is a negative expression or number under the root sign, it makes the expression becomes undefined for real number situation, but defined for complex root. So it means that we have no real numbers. As such, the root that we are going to get will be complex root. So let's see an example. We have x squared plus 2x plus 5 equal to 0. When we substitute the value of b, a, and c at their respective position in the discriminant expression, we are going to end up with an expression of this nature, which will be evaluated as d equal to minus 16. And minus 16 is less than 0, which means we are going to have complex roots. That means there is no real root for the quadratic equation. So when you plot the graph or you solve the quadratic equation, you are going to get complex root or no real root. So when you look at this particular graph, it has no intersection with the x-axis. That means there is no real value for the x-axis or any kind of answer which real numbers as an answer which will satisfy this particular equation. So here, let's see an example. We are going to determine the nature of the root of the following quadratic equations. We have the I, and I. Find the value of Q for which the quadratic equation qx squared plus 12x plus 9 is equal to 0 has real root. So these are examples that we are supposed to try our hands on and compare our answers. Good. Now let's see the solution to the work examples question. We have 2x squared minus 5x plus 3 equal to 0. We want to determine the nature of the root of this particular equation. So we need to locate our a, b, and c. So a is 2, b minus 5, and c equal to 3. Then we find our discriminant. We write the discriminant expression. So when you substitute these values in the discriminant, the answer is equal to 1, which means that the discriminant is greater than 0. And it is telling us that when you solve this particular quadratic equation, you are going to get two real roots as your answer. So hence the equation have two real and distinct numbers. That means two real roots as our solution. Now let's look at this particular examples too. That is the example 2. 3x squared plus 4x plus 2 equal to 0. So here is 3, B is 4, and C is 2. When we find our determinant, we substitute the value of A, B, and C at their respective position and end up with an answer of -8, which means D is less than 0. The moment D becomes less than 0, it means we are having the equation is having the equation has no real numbers. That means it has a complex root. So when you solve this particular quadratic equation, you are going to end up having complex root as your answer. Now, let's move to the next example, which is 4x squared minus 12x minus 9 equal to 0. So here, our A is 4, B equal to -12, and C is equal to -9. We substitute this expression into the discriminant expression, and we evaluate and simplify them to have D to be equal to 0, which means that we are going to have an equal root, only one real number, as our answer for this quadratic equation. So you can use a calculator to punch this particular answer, and you end up getting only one particular real number as your answer. So we are supposed to now solve the rest of the question, the last question, which is for us to find K, as this particular equation has equal root. Now, since the equation has been determined for A to have an equal root, since the equation has equal root, then it means that the discriminant for this particular equation is equal to 0. Then the discriminant expression is b squared minus 4ac equal to 0. So I'll substitute the value of b, a, and c in the expression. When we do that, we are going to end up with 144 minus 36 kill equal to 0. Then we make kill the subject. So 36 kill equal to 144. And kill is equal to 144 divided by 36, which is equal to 4. It means that the moment kill becomes 4, this expression will produce an equal root. Now, there is a try work for us to try our hands on them. We have to find the value of k for which this quadratic equation x squared minus 2kx plus k plus 2 equal to 0 has equal roots. So try your hands on this question. And we also have to find the range of values of m for which this equation has real roots. Here you have to use half revision on the range of quadratic equation, how to find the range of equation involving quadratic inequalities. You can use that idea to solve this particular problem. And thank you for taking part in this particular class. Don't forget to subscribe to this particular channel to continue to receive the best of high school maths education. Thank you.